Okay. Homework, W1.7, page 2. So whether this was your work from period 4 and you didn't quite finish it, you want to look at it again tonight, or whether it's tonight's homework, doesn't matter. Go ahead and do it. Make sure you're strong with this. This should look like your reference table, page 6. PRT 6. Running down the left-hand side of PRT 6, you will find all of this information. Here's a PRT. Okay. So you'll find these equations. Now, here's what we're going to do. We're going to take all of these physical quantities. Actually, I'm only going to make you do a few. But all of these different things, like acceleration, force, height, momentum, power, they all can be represented with the units that go with length, mass, and time. The basic unit that goes with any sort of length, distance, height, radius is the meter, which we'll write with lowercase m. The basic unit that goes with any mass is the kilogram, which we will write lowercase kg. And the basic unit that goes with time is the second, which we will write with s or SEC. Though I recommend sticking to S on the work we're about to do here. So, let's figure this out. The example, V. Well, what's V? If you look at the first one, notice here, first one, second one, eighth one, what we're talking about is counting from the top. Here's the first one, the first equation. Here's the second. Here's the third. You can count your way down. So the first one says V equals D over T. Here it is. And you may say, well, what's V? You can look up on the right-hand side. V is velocity or speed. But our bigger concern is not so much that. Our bigger concern is we have the equation for V. V equals D over T. This is straight off the reference table. What is D? Well, you probably would have guessed distance, but you can look over here and find it. And T is time. Well, distance has a unit of length, meters. Time has a unit of seconds. So the unit for speed is the units for distance divided by the units for time, meter per second. Now we come down to the next one, A. What is A? You can go look up its acceleration, but our bigger concern is not what it is, but what its equation would be. It is the second equation. You can pause and go find it. The second equation says A equals delta V over T. That means acceleration, or A, equals the change in speed over time. We already know the unit for V. We found it up here. V comes in meters per second. T comes in, well, we know from the very top, seconds. So the unit for acceleration would be the unit for speed or velocity, meter per second, divided by the unit for time, which is seconds. You can simplify this like we did in the notes. This becomes meter per second squared. Let's do the third, and then you'll be ready to roll on your own. This says F net. What's F net? It doesn't matter. Go find it. It is the eighth equation. So if you scroll your way down, the eighth equation says A equals F net divided by M. Now my recommendation is, since we are looking for the units for F net, let us isolate F net. This is a simple cross multiply, and when you rewrite the equation, it becomes F net equals A times M, or people more customarily write M times A. Same thing. So what can we do here? Well, we need the unit for M. You don't know what M is? It's mass. And we need the unit for acceleration, A. Well, we just found the unit for acceleration. Here it was. And we know the unit for mass. And so, the unit for F net will be the unit for mass, kilogram, multiply the unit for acceleration, meter per second squared. All of these build, as you'll see with this, P equals, you'll find M times V. V, we already have the unit. M, you already know the unit, and they all build like so. Cut.